particular series. In this video, we are going to first talk about the little bit about the life cycle of any data science project. Then we download the data, and after downloading, we will do simple EDA on the data. And also in last, I will show you how in the industry we're going to do all these things. Right. So let's start. So as you can see, this is the data set that we are going to use, fitness tracking product e-commerce data, right? So I have actually downloaded this data and keep that in our VS Code, but you can simply download from here. For downloading, you may need to create your account in the Kaggle if you don't have. So please go and create your account, and after that you can download this one, right? So let's jump to the project. So this is a VS Code. This is a simple project. You can create a parent folder called watch price. You name it anything, whatever you want. And then this is always it's a good way to keep all your things in a separate folder. Like like data, you will keep in some separate folder. If you have some script or something like some other things, like I have doc folder where I will keep some of the raw document. So always try to keep all this thing in a separate folder, right? So it will give you a project like a structure. And if your project become more bigger, it's very easy to maintain. Here you can see we have data, smartwatch data. If I click this one, you can see this there is a brand name, there is a currency price, all these things are there. So this is a CSV file, right? So what we will do, we will go and do EDA on this data. But before going EDA, I have a simple like I have written down some of the steps that we basically do whenever we are going to start any data science project. And in data science project, we have certain steps that we are following. In each and every company, the steps are different. It's not going to be like a similar kind of a step, but more or less the steps are almost similar. like like if you have a problem, then first you have to identify what is the problem, right? So somebody give you to give you a problem, you have to identify exact what is the problem. So why I am saying this one, like say that client give you something like they want to bill you, they want to give you a data, right? And based on data, they want that, okay, you have to give me the price of watch, appropriate price of watch based on such certain parameters, right? But it might also happen that during your discussion you will identify that finding the price is not a problem. Whatever the traditional way they are using, it's a good way, but finding other things like how much discount should you give on the price, right? So actual problem identification is one of the things that you will do, right? And because most of the time business people don't know these things, right? So they only know that okay, they have some data, they want to do some of the things, or sometime their analyst give you some kind of problem statement, and that problem statement you may have to understand that what they are saying, and based on that you will identify the core problem in that particular problem statement. Then once you identify what are the problems, then you have to do the business understanding. So if it is a commercial data, say that right now we are using a data of like sales data, right? Where we have you have a watch price, brand name, what are the components in a watch, and based on that the price is going to consider, then discounts is going to consider, right? So it's a sales data of a particular watch. So little bit about the how sales is working, all these things you have to understand. It's a business domain thing, right? Then you will do data collection simply. So data collection is one of the most major part, right? So whenever you start any data science project, one of the most crucial thing is to collecting the right data. There might happen that you have several source of data, like one data coming from the database. In the database also you have like NoSQL database, you have SQL database, it's a relational database. Then you have data from some website where you have to scrap the data, right? Some data might be coming from the data warehouse. So all these things are there, so that you have to understand. Based on that, you might have to build a data pipeline, or your data engineering team will do all this work, and after that you will collect all this data, right? And once the data is collected in the industry, we will also do some kind of agreement on the data, like what are the format of data, what are the data type of the data, all these things we have to. This the data agreement will happen, but you don't have to right now worry about that one, right? So simply we collect the data. After collecting the data, we pre-process the data, right? Pre-processing means it's a raw data, right? So raw data, we are not going to feed it in any algorithm. So we have to pre-process the data, remove some of the unnecessary data, and bring that raw data in a format that will be understood by our machine learning algorithms, right? So that is the pre-processing step. Then analyze the data. So pre-processing, analyze the data means like sometimes what happened that after pre-processing, your data is ready to feed into machine learning, right? Algorithms or deep learning algorithms. But you have to understand your data also, right? What are the distribution of the data? How your data look like? If it is an NLP problem, then what are the tokens? How are the tokens you are going to build? What kind of token you want to build, right? Whether you want to go into embedding side, or you want to go into the simple normal tokenization. So all these concepts are little bit depth when you go to the NLP, but for right now we are using the regression problem in this one. Mostly you are going to see the distribution of the data, univariate bivariate analysis you will do. You will find out the correlation among the data, and based on your finding you will do certain kind of standardization, normalization on your data. You will do some kind of feature engineering on your data, and after that it will be ready to fit into the machine learning algorithm. Then you will do modeling. So data modeling is basically this is little bit a confusing term, data modeling. Sometimes data modeling is simply about like, if you have a data, you will make that into a certain format, like a tabular clean format. It is also sometimes referred as a data model. And sometime it's referred like you will create a model and you feed the data, you will create different model and then feed the data. So this is also sometimes referred as the data modeling. After says, let's say that in the industry we never go with one and two algorithm. Mostly if you have a problem, we identify certain algorithms which will be suited for that particular data. We will take 4 or 5 algorithms, build a build a base model, and then we try to do ev- evaluation and monitoring of all the models, right? And based on that we will figure out one true model, 1 or 2 models which we are going to use actually. And based on that 1 2 model, we are going to train that model and entire data. And after training we will simply do deployment. Training is also not a straightforward step. In that particular step we will do so many things, like training, after that hyperparameter tuning. After we may also see what are the metrics results are there. Based on results we will do other uh, again we will go and change some of the parameters. So these all things will happen, but for now we just consider it's a model training part. After that we will do deployment, and the deployment mostly we are going to use Docker. So all these things you are going to see in this project. So let's jump into the practical. So for that what we will do, we will simply create one file, main dot, sorry it's a mistake, right? And then you have to select a kernel here, right? So kernel we are going to select this one, watch price. And first we need to import one package called pandas. Okay, so it's saying that they want to install iKernel package. So this might also happen to you if you have freshly created this environment. It might also happen that this panda package might not be there. So as you can see, no pandas is there. So install the pandas again. Package is installed. Now let's start again. As you can see, now pandas is importing. So meanwhile, what we will do, we will create a data path. For data path, what we will do, I think that's the path. And then what we will do, we will import the data and run it. So simply what we will do first, we will try to see what the data is. So I will do head. If you do head, right, so it will give you the first five value of the data set. So this is the first five value. And whenever we are doing these guys of, this is also a part of analysis, right? We are seeing the head of the data. First time we are seeing the data in actual tabular format. So whatever the findings you will find in your brain, it it might happen that you will not find significant, means like meaning from that one. But it's okay if you find any kind of significant meaning or anything that you think that I am going to use that one in further processing or something, you will simply write down. So what I personally do that one. So say that here you can see this is not going to use. Right? It's just a index, right? So what I will do, I will simply put this one. Sorry, I will copy this one. I will put here and I will just write remove, right? So in further maybe I will remove that one. Then there is a brand name. So you can also remove brand name, but sometime it might happen that based on brand, the price of the watch or the discount may vary. Like price on a Apple watch is like discount on the Apple watch is might different from the discount on the some of the watch like noise and firebots, right? So based on brand also might we might find some kind of value. So leave it that one. Current price you can see, right? This is the current price, this is the original price, and this is a discounted price. So they these three I think somehow is correlated. At least these two one, right? So based on any two value, I can find the third value, right? Based on like original price and discount, I will find the current price. And based on the like current price and discount, I will find the original price. So we may have to do some kind of feature engineering on these three columns. So for now, so if you want to write, you can write that one. For this I will get also in the later time. So I will not write now right now. So rating also it's fine. Number of ratings are there. This might we will help. This might be helping if we are going to give some kind of weighting during the training, right? So it's give it model name. I don't think it is going to give any kind of significance. So for now, just leave it that way. We will do some kind of correlation and then see what is this model name is correlated with the discounted price or the price part, right? These all are the things, features of any watch. So we also have to see what are the things are there. And also here you can see like 30 to 35 to 50 grams are there, 50 to 75 grams are there, right? So this is right now, it's not in a way that we are going to feed this data into the algorithm. Either we can make two feature from that, like high and low, or we can might take a mean value from there, right? So that also we can do. So you can write that one if you want. I'm not going to write because I will find these things also when I am doing the univariate analysis. Okay. After that, what we always do, so we always do like shape part. So I will find. So as you can see, it has 450 rows are there and 16 columns are there. So 16 features are there and 450 data points are there. So this is a very small data set. In any machine learning problem, this is considered to be a very small data set. But this video is only for like giving you a template to build any kind of project. So this might work for us. We will see what kind of result we are getting. But this is a very small data set, especially if you are going for a deep learning. After that, what we will do, see, whenever we are doing any kind of analysis on the data, we first keep our test data separately. We don't do any kind of analysis on the test data. So we take that test data and keep that somewhere, right? So we only do all the analysis on the training data and do training and all these things on the training data only, right? So what we will do, we will separate that one. For that, I will use sample and I will take the part for 80% and random state. I will keep anything. Now let's see whether it's working or not. Yeah, it's worked. Now keep the test data frame. So I am taking this that train df and all the indexes I'm dropping from the actual data frame, right? And let's print all of this train df and sorry, save. See, so this is the divide. So we will keep that in this way only. So we are going to do all kind of analysis on this train data. So let's take this, copy this train data and see what are from the below how the data is looking like. So this is the data the same way, the way it's looking in the head part, it's looking there only. So it's okay. Now after this one, what we will do, we basically find out what other data types are there. Dot. So as you can see, there are one integer value which we are going to remove, unnamed. Then we have some float value, float 64, and then we have some object value. So object value is basically a string value. So this object value are there, right? And then what we will do after this one, we try to see what are the null values. But one thing we have missed in this one, sorry for that. So what we will do always, after taking this one, we remove duplicates. I think this is the code. No. So let me see what is the code for that one. It's drop duplicate, I think. Drop duplicates. Okay. And this is equal to, when we do in place in equal to true, so what it will do, it will remove the duplicate there itself and keep the fresh data. Now see what is the shape. 450 is there, so no duplicate data is there. So basically we have to remove the duplicate data. Then we will do all these things. Now let's see what are the null value in our data, like train df dot is na dot sum. And here you can see there are so many null values are there in this one, and here also null value are there. So we have to handle all these things like null value. If you want to write, you can write this one like null value, so you will remember. So here what we will do, we will see the shape, right? And then we will see what are the data types are there, what are the null value are there. So for that, why you know you have to do something like traindf.info, and you will get all these details like 360 entries are there, and from there you can see these values are there like 360 values are there, and here you can see 3 4 value are there. So based on that you can consider there are some null value data type also you are getting. And one thing you will mention here, you will see like 4072236. This is happening because we have not reset our index, right? So we have actually we have actually where it's gone. Here we have taken the data, but we have not simply reset the data, right? So what we will do, we will take this data, right? And here we try to reset the date index. Set, and like that also we will do for test also. Reset index. Now let's see what this is giving. Now you can see it's coming from 0 to 259, right? It's a start index, a start from 0, it goes to 259. So we have resetted the data. After all these things, what we should use, we should try to see what are the statistical value we are getting. So before that, what we will do, we will divide this data, train data frame into numerical data and continuous data. So let's divide that one, because a statistical value is coming differently for numerical data and different for the continuous data. So what I will take, I think for feature in train data frame. So from I will looping here for all the columns, and I will put some condition here. If train df dot feature not equal to object, right? And I will get, there is some problem. Let me see what the problem is here. Okay, the type I have not mentioned. Yes, it will go like that, and I will copy this one, name it this one, continuous feature and equal to object, right? And if I print this one, you can see all this data are numerical data. And after that, if I print continuous data, these all are the continuous data. Brand name, these model name are the continuous data. So let's first take the numerical data, right? And try to see the statistical value of that data. So I will simply put and then describe the data. So from describe, you will find some of the value like count, mean, standard deviation, what is the minimum value 20, in 25%, what is the minimum value 50%, for 75%, and what is the maximum value, right? So index and a name zero, we will not do anything with that one. So for current price, okay, so count is 354. So one thing you need to understand, it is also taking the null value in consideration. It might happen that there are some null value in your column, right? And based on that null value, it's giving you a mean value. You know the formula like sum of all the data by the number of data by which we getting the mean value, right? So consider that one in your mind also. You can see that the mean value is this one, original is it none, this one, and 45% they are giving the discount, right? So if you see the discount by price, so only minus 79% minimum. I don't think what this meaning is. Minus 79%, it might be happen that if it is a minus, so I'm considering that price is increased rather than decreased. Also here 91% discount they are giving. In which watch I have in real time I have never seen 91% discount in any watch. So these all things you have to see, and based on that again we need to see the data, actual data, and figure out why these things are coming. That might be a question for your data owner also and the person who are owning the data. These might be the question. Some of the thing you will take from here, right? And after doing all this one, you also need to check the correlation of the data. For correlation, simply you will take this one and then you will just simply call this function correlation function, and you will find out the correlation. So all the diagonal value, see, this value is index, it is 100% correlated, right? That they have 100% match, and then this one is also 100% match because this index and a name is the same, so they are giving the 100% match, right? So if you see, I want to see that what is the relation between the original price and the discount, right? Like current price and the discount. So let's say current price and here is the discount. So there is a negative 60% relation is there, right? So these kinds of things you will find out from the correlation, and then you will find out what are the features which are highly correlated that you need to remove, or you need to do some kind of feature engineering of that on that particular data. These all things we will discuss once we go on the feature engineering part, right? So and then also you can see how the skewness of the data. So skewness, whenever you do any kind of data distribution, you will see in normal curve, bell size curve, how skewed the data is, whether it is a left skewed or it is a right skewed. So if you see, you can see there is some kind of a skewness are there, right? So that also we will see once we further go, right? So, but all these things, right? Whatever we have done right now, this is a part of simple data analysis part, EDA parts, where we do the data analysis on the data. But in real time, we are not going to do all these things, right? We will write all these things like simply we try to find out the data type. Some in a starting we will not do these things. We will do later part when we have to do some kind of a specific task on a specific data point. So what we are going to use, we are going to use one package which will give you a very simple way by which whatever we have done until now, it will be done. So for that, we will use this pandas profiling. So this pandas profiling you can take and you can install, right? So let's install this package first. So I'm installing this package. It might take some time. and then it will install. And then what I will do, import y data dot profiling as pp. I think that is there. After that, what we will do, pp dot profile report. I will pass the data frame. No model that. So let's see what is the problem. I think some package might not be installed. Yeah, this is there. Let's take that one and install that one here. Then see. It's processing. So let's close for now this one. Now you can see in this one, there is a nice HTML page are there. You can save that in a file also, but right now we are using inside the Jupyter notebook itself. So there are some menu bar are there, where if you click on any menu bar like in variable, yeah, in this one, it will jump to a particular section of the page, right? This is a menu bar where you can overview variables, interaction, correlation, missing value, and sample, right? So if you come to the first section like overview section, in overview section you can see this is simply the info part of your data, right? So info part of your data, like it's saying that number of variables are 17 is the feature, number of observations are this only this much, these are the missing cells are there, total missing cells, percentage of the missing cells, 11.4% of your data is missing, right? There is no duplicate row. So 0 is their total memory size, average read memory size. So these are the things are there. Like here also it's giving you like how many numerical variables are there, how many categorical variables are there, and how many yes and no boolean variables are there. It's also giving, right? And there are some alerts are there. But this is one of the most important part. I personally love this feature. So whenever we do this kind of data profiling, I always first go to this alert part and see there is highly correlation is there, like model name has 311 distinct value. So why it's saying that model name has 311 distinct value? Because in this data set, almost all the data is there for one particular brand. That's why it might happen that model name is this distinct value. No, sorry, it's opposite thing I'm saying. Distinct value is different like values are there for that model name. Now high correlations are there. You can see for index and unnamed, you know that these are the highly correlation. You can see the relation between the current price and original price. If you want to see high correlations are there, these all things are there. You can see like missing value, how in Bluetooth you have 93.0% are missing value, and there are some imbalance are there, right? So these all information you will get here. And if you give on the reproduce, I don't think this is any useful. This is simply the configuration of this particular file. If I go to the second part, you will see the variables like df for each particular feature. You will find there a description for that one. So I will go for the brand part only, right? So we have 18 distinct brand are there. The 5.5% distinct are there. If you click on the more, you will find some of the more details about this data. Then you will find the percentage. It's a nice graph it's giving you. Then words, what are the words are there, characters are there. These kinds of analysis you will do on this one, right? And then if you go to this interaction part, so this is one of the most important graph you will find in this data profiling. We will where you will take like battery life and say I want to see the discount, right? relation. Is there any relation between the discount and battery this battery data? I don't think there is a relation, but it's mostly not in a way like some kind of functional relation is there. If I check discount and original discount, and I will say current price. See, so whenever it's a higher discount, the price of particular data is low. Means can not take the current price, take the original price. So you can see if you have a higher discount, the original price of watch is very low. Means like cheaper product have higher probability of getting a higher discount. If you have a costly product like 80,000 or some products are there which are original price, you will get very less discount in that one. So these kinds of information you will take, and here you can see a correlation graph. The correlation like each value is a how much correlation with the other one, right? So simply if it is like 80%, 0.80% or higher is there, it's a highly correlated, and we will do feature engineering on that one. Also, this is a question of that you should ask with your data owner, that how much correlation you will you basically want in your data, or tolerable in your data. But also when you are doing a statistical analysis based on the algorithm, you will also do ups and downs and pick ups and downs and do feature engineering on that one, right? So I think these are the missing values are there for each and every features, and then these are the sample data are there, first and last. So it's like a head and tail is there. So whatever we have done through coding, you can simply do all these things by data profiling, right? So I think it's going to be long video, so I will stop this video here. In the next video, what we will do some of the custom visualization based on our data. We will try to find out inside what are the things we will do on top of this data analysis we will do on top of this data. And also we will take a approach where this data should be cleaned, and after cleaning of the data we will make this data useful for the algorithms, right? So stay tuned. If you have any question, please ask in the comment.